Hello, my name is Andrew, and for my final project, I wanted to implement BlendShapes in a 3D environment using randomly generated shapes. Here's a quick look at the results. BlendShapes is a technique where a single mesh or shape represented by a network of vertices and edges can be manipulated to achieve a different shape. The final result is obtained through a linear combination of all the blend shapes in between the starting shape and the target shape. This is done through linear interpolation, and we can include other transformations, such as rotation, to produce a more appealing animation. For this simulation, I start off by creating two separate shapes, one being the starting shape and the other being the target shape. These shapes are generated using the following formula. A, B, M, and N1 through N3 are all real numbers, but A and B cannot be zero. Altering these values will produce some shape in 2 dimensions. To extend the shape into a 3-dimensional spherical shape, we define the x, y, and z coordinates as the following. To calculate these angles, I have a nested loop that iterates from 0 to the number of triangles used to build a mesh, or the level of detail. I then scale some value of I from 0 to the number of triangles to a range between negative half pi and half pi to calculate phi. To calculate theta, I scale some value j from 0 to the number of triangles to a range between negative pi and pi. These shapes are stored as a 2D array of vectors, with each vector representing a point in the 3-dimensional space. For each frame, we linearly interpolate the starting shape by some amount and then draw the interpolated shape. The following formula can be used to lerp between 2 points. The lerping continues until the target shape is reached. The result of this process is an animation where the object appears to morph or blend into something else. You can then press a space bar to generate a new random shape. To further showcase the blend shapes, I have also implemented rotation. We can represent rotation in a 3D space with the following matrices. Each matrix describes the transformations from one coordinate space to another. An issue I've encountered while working on this project is that some values for the shape formula can result in an unstable shape. These unstable shapes appear to stretch out indefinitely, but as you move the camera, they pop in and out of existence. Some unstable shapes can only be viewed from specific angles, or else it will disappear entirely. Another issue I've encountered was the order of rotations. If I perform some rotation on the z-axis, then the x-axis, and then the y-axis, you can get a result similar to gimbal lock, where the shape loses a degree of freedom in its rotation. I then recreated the simulation in Unity using quaternions to completely avoid gimbal lock and see the difference. Very cool. A state-of-the-art technique I have tried to implement for blend shapes is a simultaneous simplification of triangle meshes. As mentioned before, the shape is rendered using a network of interconnected triangles. Increasing the number of triangles increases the resolution. However, this in turn reduces performance. Thus, the goal of this approach is to reduce the number of triangles while minimizing the loss of detail by reordering the triangles to simplify the mesh. Here are some results.